Today we're covering 9.7, which is about variations. So in this section, we're going to actually look at a direct variation. So a direct variation kind of goes along this verbiage. You're going to say something like, y varies directly with x, okay? So y varies directly as x. You could have different letters. You could have K, you could have Q's and R's or S or T's, but you're going to have one variable varying directly with another variable. And so the order of how these goes affect our equation. So if we say y varies directly as x, if y equals k times x. So y varies directly with x. So we have y equals, because y was varying, directly, that has the multiplication of the k times the x. And so that k that appears in that equation has to be a positive constant. It's not going to be negative. It's going to be a constant. So it's going to be some coefficient. We call that k value our constant of variation. So that's what's always going to be multiplying by x to get the y. So you'll notice as your x increases, so does y, because the x is being multiplied. And so if x is getting larger, so is y. And then that increase that we have in y as x increases, it's going to be directly proportional to x. That's why we have that constant of variation. So the equation y equals k times x, this is the general form for a direct variation. This is your general equation, y varies directly with x. However, we have been studying quadratic equations, and so we can actually look at if y varies directly as the square of x. So that will look a little different. So we're going to look at as y varies directly with the square of x. So the square of x just means x squared, right? So that general form will look like this. Y equals k, we still have that constant of variation, x squared. So notice that we're not going to have any plus or minus constants over here. It's just going to be k times that x squared, okay? So this is our standard form of parabola with its vertex at the origin, because there is no h or k value. So your parabola will be at the origin here, okay? So let's look at some examples. Let's say that, let's look at example 1. Let's say the area of a circle, so the area of a circle varies directly as the square of the radius. Okay. And the question is, write the equation of this variation and give the constant of variation. Okay, so first thing we want to do is write the equation of the variation. Okay, and then the second thing we want to do is give the constant of variation, which remember we call that k. So there's two things that it's asking us to do, okay? So since area is varying by the square of the radius, that means area kind of represents our y. So we're gonna, but instead of saying y, since we're dealing with area, we're gonna say a equals, and then we know that we're gonna have some constant k, and then our radius squared, okay? So now we've defined the variables, okay? So what is the area of a circle? So you have to kind of think back into geometry and think of all of those formulas that we have learned in geometry. So one of those formulas was the area of a circle, which was pi r squared. So that means that our constant of variation is going to be, our constant of variation, our k, is going to be equal to pi, because we always multiply whatever our radius squared is by pi every single time. Anytime we're trying to find the area, we always multiply by pi, even though the radius changes. Okay, so our constant of variation will be pi. Our formula, our final formula, will be a equals pi r squared. All right, let's look at another example. Let's say we have if y varies directly as x. So that gives us the general idea of what it's going to look like. And y equals 8 when x equals 1/2. We want to find y when x equals 4. So the first thing that we need to do is figure out what our equation is. So we know what the general equation is. We know that it's going to look like y equals k times x. But right now, this is not like a formula like we did in example 1 where we knew the formula was pi r squared. We knew that that k had to be pi because that was the formula that we learned in geometry. But for this example, this is not following a geometric formula that we know. We have no idea what this k is, this constant of variation. So before we can begin, we have to actually get our equation, our direct variation equation. And so we have to figure out what that y is, or what that k is, before we can move on. So what we're going to do, we're going to use our given information, which is y equals 8 when x is equal to 1/2. We're going to use that to find k. So step 1, we have to find k. Okay, so to find k, we're going to substitute y equals 8 when x equals 1/2. Then we solve for k. We multiply 2 on both sides, which means k is equal to 16. Okay, now that we find k, step 2 is going to be write equation, okay? But we're going to not write y equals k times x. We're actually going to write what k is. We want our final equation. So in order to find any y, we had to multiply x by 16 because k is 16. So now we can answer our final question. We can find out what is y when x is equal to 4. Now we answer what is y when x equals 4. Well, we substitute x for 4. So now we have y equals 16 times 4. And then 16 times 4 is 64. Okay? So there are 3 steps to this. Step 1 is find k. Step 2 is to write the new equation. And then step 3 is to actually answer the last question. Okay? So if you try to just do this part without finding your k first and without writing the new equation, you will not be able to do this. You have to follow these 3 steps. All right, let's look at something different now. So sometimes we have 2 variables that are not related directly, but inversely, okay? So now we're gonna look at inverse variations, okay? So this means as x increases, y decreases, Okay, so as x increases, y decreases. So now before in the direct variation, as x increased, so did y. But for inverse, it's opposite. As x gets bigger, y is going to get smaller. Okay, so the general form of an inverse variation, so remember the general form of direct was y equals k times x. So the general form of inverse is going to be y equals k over x. So that k is still going to be a constant of variation. That k is still going to be some constant that we're usually going to have to find before we can answer our question. Okay? So let's talk about why we use this. Let's say we have this formula, f equals k over r squared. Okay? This is an inverse variation, and this formula describes the gravitational force between spherical objects and the square the distances between the centers of gravity. So this is something that you'd find in physics, this type of formula here. Okay? So in this equation, f is varying inversely as the square of r, right? Remember, r was the radius, f was the force. So f equals k over r squared. So let's look at some examples using inverse variations, okay? So let's say if y varies inversely, so it means that we're going to use this general form, as x cubed, okay? So instead of using x, we're going to use x cubed, okay? And y equals 16 when x equals 2. Now we can find our k because they gave us information, okay? And then find y when x equals 8, okay? So first thing we do is we have to find k, right? Before we can try to solve, and before we can find y when x equals 8, we have to get the equation. To get the equation, we have to figure out what k is. So we set this up. We know that y varies inversely, so k over as x cubed, all right? So we know that it's going to look something like that, but we have to find what k is. It says y equals 16 when x equals 2. So I'm going to plug in 16 for y and 2 for x. Now I'm going to solve for k. So let's see, this is 16 equals 2 cubed is 8, right? And then that means k is going to be equal to 16 times 8, which is 128. So now I know what k is, which means I know what my equation is. My equation is going to be y equals 128 over x cubed. So now the question is, find y when x is equal to 8. So what is y when x is equal to 8? So 8 cubed. So 8 cubed is 512. So I have 128 over 512, which reduces to 1/4. All right, let's do another problem. This one will be more of a word problem. So for this one, we say that the temperature remains constant. Okay, so we're looking at example 4 here. And we're saying that temperature is constant, which sounds to me like that means that it's going to be our constant of variation. Okay, it says the volume of a gas, so volume of a gas varies inversely, which means K over something, okay, with its pressure. Okay, so varies inversely with its pressure. And it says if a certain gas has a volume, so that's V, of 25, at 15 pounds per square inch, which is psi, okay, and that's pressure, okay. PSI is pressure. 15 pounds per square inch is your pressure. Oh no, I'm sorry. 25 cubic inches at 15 pounds per square inch. And the pressure is increased to 20. What is the volume after the pressure increase? So we have, when it was 25 cubic inches, the pressure was 15. And the question is, okay, well, instead of 15, what if you have 20? Sorry, we don't know what we're saying. If you have, instead of having a pressure of 15, if you change it to 20, what is that going to do to your volume? How does that affect the volume, right? So what we have to do is we first have to solve for K, and then once we solve for K, we'll know how to solve for the volume of our second situation. So we multiply both sides by 15. So 25 times 15 is 375, which means the volume of our new situation is 375 divided by 20, which means that our new volume is going to be 18.75. Okay, so that's another, that's a real life example of inverse variation. So again, this is really useful for when you have to take physics, because this is one of the formulas that you use in physics. All right, so sometimes variations have more than two variables, and they are called combined or joint variations. So that's what we're going to talk about now, combined or joint variation. So this is when you have more than two variables. Okay, so we have combined or joint variations. Okay, and all this means is that means you have more than two variables. Okay, so the verbiage for this sounds like something like this. If Z varies jointly as X and Y. The joint variation is given, so this is the verbiage. If Z varies jointly as X and Y. So the general form of this is going to be Z equals that K value, again, that constant of variation, which we have to solve for, times X times Y. Okay? So it can also be a mixed direct and inverse variation. So an example of that would be like in example 5, where you have something like this. It says, write the general equation for this statement. So here's the verbiage. Y varies directly, which means times K, right? As the sum, so it means we have to add some stuff together, of X and Z. All right, so we're going to multiply K by X plus Z, but then also and inversely as the square of X. Okay, so we know that we have the direct part. The direct part means that you're going to multiply by K, right? So we know we're going to multiply K, the sum of X and Z. So we know we're going to have Y equals K, and since it's directly, we're going to multiply it by X and Z, but it says the sum of X and Z, so we're going to put X plus Z and then close our parentheses. But then also, here's the next part of it, it also is varying inversely with the square of X, which means divide by the square of X, or divide by X squared. All right, so as you can see, there's a lot of different ways you can write variations. So you have to pay attention to the verbiage, right? It's almost like writing an expression. So you have to be able to translate it into an equation. So there are 3 types of variations that we talked about today. There is the direct variation, there was the inverse variation, and then there was the joint or combined variation. So go ahead and try some problems on your own.